Okay, Mr. Baumer, coming with you live today from the math department office, but I'll give you a chance here. I want you to be writing down the objective there at the bottom of your paper. All right, we're in lesson 7-6, and today the objective is that the student will be able to classify polynomials and write polynomials in standard form. So while you're writing that down, just make sure you're listening here. We're going to be classifying these things. All right, now you guys are used to being able to classify things, and things can be classified in more than one way. We could say that all of these things are short, but they could also be very expensive. You know, they could be ugly. All right, they could be colorful. All right, so we can give more than one classification to a single thing, in this case being a polynomial. All right, so we're going to have to learn these terms. Today's very term intensive. All right, usually we get a lot in the example column and a little bit in the background explanation column and very little in the vocabulary column. Well, today it's kind of mixed up. We got a lot in the vocab and the background column and a few examples to go through. So we're going to learn how to classify polynomials, and we want to be able to write polynomials in what's called standard form. Now, of course, you remember standard form from linear equations was ax plus by equals c. All right, but this standard form means a little bit something different. All right, so we're going to have to make sure that you understand what exactly that means. So hopefully you've gotten the objective down, and now if you go on to the next page, here we go. All right, I want us to start off over here. Let me make it a little bigger in the vocabulary section. All right, so what does polynomial mean? Well, polynomial really means, if we break it down to its two roots, all right, poly meaning many and nomial meaning number, but really meaning terms. All right, so many terms. Now, what is a term? And this is actually something that you'd think at this point that it'd be fairly easy for a student this late in Algebra 1 to identify a term, but a lot of students have a little misunderstanding of that. All right, a term is part of an algebraic expression that are separated by plus or minus symbols. All right, and a lot of students fail to recognize that. So let's just kind of apply that right here. If we're looking at this right here, 3x squared plus 4x plus 3, how many terms are there? Well, again, it's the parts of an algebraic expression that are separated by plus or minuses. So this is separating some terms, and this is separating some terms. So that means that we have 3 terms. Now, if you look at this one, see, a lot of students would look at this and say, all right, the 12 is a term, the x squared is a term, the y to the 5th is a term, and the z to the 12th is a term. No, that's all one single term. All right, the only term in this expression is 12x squared, y to the 5th, z to the 12th. All right. Now, in this one, how many terms are there? Hopefully the answer 2 just came into your head. All right. Now, in terms of the classifications we're going to do, let's look over here now, over in the background explanation area. All right. So we're going to classify polynomials based on 2 criteria. All right, 2 things. So there's going to be 2 parts to our name when we name a polynomial. There's going to be 2 parts. One of those is going to be based on what's the degree of that polynomial. And we'll learn about what degree here means here in a minute, but let's look here. If we have a degree that we determine, and again, we haven't learned how to determine it yet, but if we have a degree that's a 0 degree, we're going to call that whole thing a constant. Now, if it's degree 1, and we've been working on these, all right, that was all of Unit 5 was about things that are degree 1, all right, meaning the x is to the power of 1. We call those linear. Degree 2, well, if you remember back earlier in the year when we were graphing some things, when the x was squared, those graphs formed parabolas, which the family of function, the type of function that is a quadratic. Now 3 is going to be called a cubic. Oops, I just typed over that, sorry. 2 is a quadratic, 3 is a cubic, and 4 is a quartic. All right, 5th is a quintic, and after that we just use degree 6, degree 7, degree 8, etc. All right, they don't have special names. So these are the ones that will suffice really for Algebra 1 for us to be looking at. Now, that's one of the criteria that we're going to classify a polynomial on is what's the degree of the polynomial. Now, what's the other classification? Well, it's going to be based on the number of terms that make up those polynomials. So, if there is one term, we're going to call that a monomial. If there are two terms, we're going to call that a binomial. Oops, just typed over that again. Okay, sorry, I got distracted there a little, had someone come into the office. But again, now we're looking at the second way we're classifying these polynomials, and the criteria is how many terms are there in the polynomial. Now, obviously, if there's 0 terms, we wouldn't call that anything. It wouldn't be a polynomial, all right? It'd be a blank space. But if there's 1 term, it's a monomial. If there's 2 terms, it is a binomial. So make sure you're getting these notes down. All right, if there are 3 terms, it is a trinomial. And if there are 4 terms or more, we just refer to them. This doesn't have a special name again. All right, we just refer to them as how many terms. So it's a polynomial of 4 terms. All right, so if it was 5, it'd be a polynomial of 5 terms. 6, polynomial of 6 terms, etc. All right, so again, we're going to classify polynomials based on the degree of the polynomial and how many terms there are in the polynomial. So we better learn how to look at the degree of a polynomial. So let's come back over here. Let's come back over here to the vocabulary section. All right, and let's talk about this word degree. All right, because it's actually it's not so bad. All right, the degree of a term. So this is important. The distinction here is that we're talking about the degree of an individual term. So if you look at this one right here, there is only 1 term. So how do we find the degree of it? Well, it's the sum of the exponents on any variable parts of the term. So if we're actually looking at this, we're looking at, well, there's a 6 here, there's the implied 1 there, and there's the 2 there. So the degree of this single term, of just this monomial, would be 9. Right. Now, what about, that was the degree of a monomial, of a single term. What about the degree of a polynomial? And this is the one that's really important. All right, we're going to use this one more than this. All right, in terms of classifying it, we base it on the degree of the polynomial. So, the degree of a polynomial, it's the degree of the highest degree term. All right, so if we apply the logic up here to this one, this term right here is a 2nd degree. This term right here is a 3rd degree. And this term right here would be just a constant. All right, so that's just a constant, otherwise known as degree 0, but for our purposes it's a constant. Now, what's the degree of this polynomial? Well, it's the highest degreed term. So this one right here is telling us what the degree of the polynomial is. It's a 3rd degree polynomial. All right? So it's really, I mean, as long as you just have 1 variable as part of each term, you're really just zeroing in on, hey, what's the highest exponent? All right, more often than not, that's going to get you where you need to be. Now, let's talk about this thing's standard form of a polynomial. Well, terms are written in descending order of degrees. So this one is the 8th degree, the 5th degree, the 1st degree, and the 0 degree, or our constant. All right. So when we're writing things in standard form, we write them in descending order of exponent. All right. Now, this concept of this leading coefficient, another vocabulary term. All right. Vocabulary is very big in this lesson. It's the coefficient of the highest degreed term. So, what's the leading coefficient of the polynomial above? I misspelled polynomial there, but we're looking for the highest degreed term. So the highest degreed term is right here. And what is the coefficient of it? Well, hopefully 5 was coming to mind. All right. So the leading coefficient of this polynomial is 5. All right. So again, just kind of looking at this from a big picture point of view. All right. We're going to classify polynomials based on degree and based on the number of terms. And we've learned how to look at the number of terms and the degrees of both the monomial and the polynomial. So let's try and do just 2 examples here, and then we'll be done. What type of polynomial is this? All right, it's asking me to classify it. Well, if I notice, the degree of this polynomial is 3, and the number of terms is 3. So I just need to know these vocabulary words. All right, this terminology is important because there is a 3rd degree. That makes it a cubic. Because there are 3 terms, that makes it a trinomial. So this is a cubic trinomial. All right, that is a cubic trinomial. So let me move it over a little bit. This is a cubic trinomial. That's the type of polynomial it is. All right. What's the degree? Well, we already kind of talked about that. It's a 3rd degree. All right. Because we're looking for the degree of the entire polynomial, we find the term that has the highest degree. Write it in standard form. Well, remember, standard form goes in descending order of exponents. So we should be writing the 3rd degree term first, then the 2nd degree term, if there is one, and then, of course, we have a 1st degree term over here. All right. What's the leading coefficient? Well, if we take the time to write it in standard form, the leading coefficient will be just the first coefficient, which is 4. All right. But remember, that's only after we've written it in standard form. Really what you want to look for is what's the highest degree term and what's its coefficient. Now, consider this one. What is the degree of this polynomial? Well, this term has a degree 2. This term has a degree 4, and this term has a degree 0. So the polynomial degree is determined by the largest of these. So it's 4. So classify it. Well, it's a 4th degree with 3 terms. 4th degree with 3 terms. So again, 3 terms means it's going to be a trinomial, and 4th degree means it's going to be a quartic. So if we're going to classify this, then it is a quartic trinomial. It's a quartic trinomial. Now, write it in standard form. Well, again, standard form, just descending order of exponent. So 9x to the 4th plus 18x squared plus 4. Now, what's the leading coefficient? Well, the highest degree term is this one. And what's the coefficient of it? It's 9. Now, here we're asking you to make one up. Write a quadratic binomial with a leading coefficient of 2. And I'm going to leave that for you. I want everybody to write their own. Write a quadratic binomial with a leading coefficient of 2. Quadratic tells you something about the biggest exponent. Binomial tells you something about how many terms need to make up your expression, and the leading coefficient tells you something about where a 7 needs to be in your answer. All right, so there's more than one right answer here, but give it your best shot. All right, so here we go. That's the lesson for today, and if you bring your completed notes in, we'll spend some time in class practicing these concepts. Thanks.